Okay, entonces now the idea is decompose and partial fraction decomposition, no? So the first thing you should do is factorization. Factorization, the expression in the denominator, que I saw que es the differences of the square. Look, let me recall that formula que we studied in intermediate algebra. Something like that. Therefore, this is x minus 1, because a is x, b is 1. And the trinomial, we have x squared plus x plus 1. Okay, by the way, this is irreducible quadratic because the solution of this is imaginary. 3x minus 5. And the format for the partial fraction decomposition is, we have one real non-repeated 0, que es 1. X minus 1. And we have another que es irreducible quadratic, que es imaginary. Entonces, x squared plus x plus 1. And you put here a arbitrary letter, bx plus d, plus c, sorry. Remember, when it's quadratic in the bottom, it's linear in the top. This is the typical format of the partial fraction decomposition. Okay? I promise que you see, we using in Calculus 2. Of course, the professor que explained Calculus 2, again, is repeating this idea, no? Because maybe you forgot, but you see the movie one time and you refresh your memory. No? Okay, now multiplication, the least common denominator obviously is LCD, is both together, is x minus 1, x squared plus x plus 1. And when you multiply this expression, the whole expression, times this, stay 3x minus 5, equal a x squared plus x plus 1, plus bx plus c times x minus 1. Do you follow me? Everyone understand very well this part or not?
Yes, sir.
Okay. And remember, you take advantage what is the name is a good value and frame value. No? Frame value. What is the frame value? Frame value is 1. No? Because when you plug in 1, at least that part disappears. You allow me to compute a. So it's 3 times 1 minus 5 is equal to a, 1 squared plus 1 plus 1. This is negative 2 because 3 minus 5 is negative 2. And this is 1 plus 1 plus 1 is 3, 3a. Therefore, a is equal to negative 2/3. A is equal negative 2/3. Okay, but unfortunately, we have only one frame value. I need good value. Suppose I select 0. 0 is good, excellent, good. So you, for example, select x equals 0. You have negative 5, obviously, right? Because 3 times 0 is 5. Y ahí take advantage, que no, que a es negative 2/3. Entonces 0 squared plus 0 plus 1 is just 1. And plus b times 0 plus c and 0 minus 1. Entonces this is negative 5. This is obvious que es negative 2/3. Plus this part disappear. And this is c. Actually, it's negative c, not positive 6, because it's negative 1. So negative 1, negative 1, negative 1, negative 1 is negative c. Let me erase that part. It's negative c. If you don't like, the negative answer, you multiply the entire equation by -1. So phi is equal to 2/3 plus C. And so for C, C is equal phi minus 2/3. 3, the least common denominator, 15 minus 2 is 13 over 3. This is C. C is 13 over 3. Here. 13 over 3. Let's find B. To find B, we need another good value. Okay, I select -1. Entonces -1 is negative, no, it's 3 times -1 minus 5, que obviously is -8, no, because -3 and -5 together.
Professor, I'm sorry. What is the name of the equation? Like, ¿cómo se llama lo que estamos haciendo ahora?
Partial fraction decomposition. Partial fractions decomposition. The idea is, Mr. Take one fraction and break it down in several small partial fractions. Decompositions. Okay? Is PFD. Partial fraction decomposition. Yeah, no problem. Let me try. Well, no, it's okay. Now let's do it now. -1. -1 is another good value. This is good value, no frame, because frame is fantastic. Good value. And another good value is -1. The only frame in this example was 1, because delete the entire this part. Entonces es negative 2/3, que es the A value is negative 2/3. And you substitution -1, pero -1 squared is positive 1. And x alone is -1 plus 1. Okay. This -1 and this -1 is cancelled. It stay 1 and negative 2/3 is negative 2/3. Okay. Plus. B, parenthesis, B, que I don't know. -1 is x. Plus 13 over 3, que C, we compute before. Multiplication by is -1. -1 and -1 is -2, no? Because I delete the part, but it's -2, -1, sorry, and -1 is -2. Okay, so far we have -A, -2/3, plus, actually it's 2B, because -1 and -2 together is positive, plus, minus, sorry, 26 over 3, que es multiplication 2 times 13, negative, no? Therefore, 2B alone is equal -A plus 2/3 plus 26 over 3. See, you, for example, condensing this in only one common denominator, que es 3, we have -24 plus 2 plus 26. Entonces, 26 minus 24 is 2, 2 plus 2 is 4, 3. Okay, now divide by 2. Both sides. B alone is 4 over 3 times 1/2, que es 2/3, positive. Okay. I know it's too easy, but it's too long. I know. Everyone make a mistake. I want to show you after that this example, this in Wolfram Alpha. Wolfram Alpha is software que you need to understand in calculus. So this is B is 2/3. What is my final answer? What is my final answer in calculus 2? My final answer in calculus 2 is this fraction, que es 3x minus 5, divided by x cubed minus 1 is equivalent to say -2 over 3 times x minus 1, because this fraction, you know, The negative I put in the front, or either way, and the 3 I put in the bottom. Entonces you separate this, why not, in 2 pieces, no in 1 piece, into like that. Like that. X squared plus X plus 1. And this is 2 positive, and this is 3. Here, get this 3. And this is 13, and this is 3 also. And this is the answer. And this is just the beginning in calculus 2 to start. Because we're using, it's like we studied in calculus 1, but in calculus 2, you apply this method for partial fraction decomposition. One operator gets integrate. So you integrate separately, and this is a scissor in each piece. Then the completed is crazy. Okay. Any question? Do you understand very well or no? Confusing. Very confusing, eh? Huh? Let me know, guys. Okay, let's do one more example. Again, this example, I try to make easy example, or relatively easy example, of the complex irreducible quadratic repeated. Okay, it's the less frequency way. Okay, you can see, but okay, at least one in your life. X cubed plus X squared divided by X squared plus 4 A squared. And do the partial fraction decomposition. Partial fraction decomposition. But in this case, you have multiplicity too. So the idea is clear. You copy 2 times X squared plus 4 squared and X squared plus 4 raised to the 1 power, no? And you know 1 power is invisible, and you need to don't write that. And you put, for example, AX plus B, doesn't matter the letter you will suppose. I decide A, B, C, D. CX plus D. Okay, you got the idea? In this case, unfortunately, we have no frame value. We have, entonces now we're using our imagination. LCD. LCD es obvio que es X squared plus 4 squared. I multiply the entire equation. This. So we have on the left hand side X cubed plus 2 plus X squared, sorry. And this is CX plus D. This is cancel, it's obvious. And this no, and this is stay alive only one. This is AX plus B times X squared plus 4. Everyone follow me? Everyone understand the thing I am doing or no?
Yes.
Okay. So I propose you in this specific example doing in the traditional way I explained at the beginning when you start this section, is you foil, suppose X cubed plus X squared is equal to CX plus D, and you foil here A X cubed plus 4 AX plus BX squared plus 4B. Entonces now you grouping in the same exponent. Look, X cubed plus X squared. This is the only guy que have X cubed. Entonces A X cubed plus X squared is missing. No, it's not missing. Is SB. B X squared, que es this. Plus the term que contain X is this and this together. Entonces es plus C plus 4A X plus D and 4b. D plus 4b. So the thing I am doing is separate by category, no? X cubic, x square, x linear, and no x, so 0 degree. And we compare this and this polynomial. Es obvio que A es 1. Es obvio, look. The coefficients in front, the x squared is 1 and the x squared is 1. Cubic and square is the same. So A and B is 1. However, C plus 4A is 0, is missing, and D plus 4B is 0 also. Because on the left-hand side we have no x, so we have no linear and no constant. So this guy is 0. Now I know okay, A is 1. A is 1. Therefore, C is -4. C A is 1, so for C. And likewise, si B is 1, D is -4. Okay. This is elementary example, guys. I promise que another example, maybe in calculus 2, no, with me, is very, very complicated. So let me write the final answer. The final answer is C is -4. So -4 x minus 4 divided by x squared plus 4 x squared plus A and B is 1. Entonces x plus 1 divided by x squared plus 4. And it's the partial fraction decomposition of this example. Okay. This is equivalent 100% identity. This x cubic plus x squared divided by x squared plus 4 squared. The problem is this is hard and this is easy and this is easy to manipulate, at least in calculus. Because I propose you. Let me try. You follow me, guy? Everything okay? Come on, opinion.
Yes.
Opinion.
Everything's all right.
Problem. Okay. Let me go open now the new topic. Que is system of equation, but non-linear system of equation. So the next topic we are discussing now is system of non-linear equation and two variables. Systems of non-linear equations in two variables. And three variables is crazy. Yeah, more than two variables is super crazy. Equation. I forgot here A. Arajo. Okay. Again. Equation. Bueno. Typing equation. Equation. Don't allow me. No. Equation, guys. I forgot A here, right? You know that. Okay. What is the idea? Let me understand what means non-linear. Okay, suppose. See, at least one equation is non-linear. So we solving before system of equation in two variable and three variable linear. Linear is when the coefficient is 1. So when the exponent, sorry, is 1. Linear. If the exponent is different to the 1, 2, 3, or another possibility, combination x times y is non-linear. Let's discuss in one couple of the example. Suppose system number one. System number one is minus x plus no minus 7y equal 50. Equation number one. This is my first equation. My equation number two is x squared plus y squared equal 100. This is equation number two. Let me try to understand. The first equation obviously is linear. Look at that. The exponent is 1, 1. However, the second no. The second exponent 2 is non-linear. Therefore, the system is non-linear. See, at least one is non-linear, screw up everything. And the way for solving is a little confusing. There are no systematic strategy, but what we want to discuss in similar strategy to the linear system, but it's a little bit more complicated. Another example of the system, system 2 is 2x squared plus y squared equals 17, equation 1, and x squared plus 2y squared equal 22, equation 2. It's obvious that this is non-linear, and this is obvious that it's non-linear, and for more reason, this system is non-linear. Okay, do you understand the idea for behind linear or non-linear? Okay. Now, you need to be aware that when you have non-linear, we have several weird possibilities. Remember, in linear, we have one solution, no solution, or infinity-many solution when they are coincident to linear. In 3 dimensions, it's similar. But here we have more possibility because it's no line, it's a curve, it's a circle, it's a parabola, it's a hyperbola. Okay, so now let's see different situation. This is x, this is y, x, y, x, y. Suppose in one hypothetical example, the first equation is a circle. And the second equation is a line. Okay, red one, equation 1, non-linear. Blue, equation 2, linear. And the common point is this and this. We have two solutions. It's one possibility. Suppose another example in which the equation 1 is an ellipse set like that. Equation 1. And equation 2 is another ellipse, but in this direction. Open in this direction. Equation 2. But we have 1, 2, 3, and 4 solutions. Well, another possibility is we have, for example, we have equation 1 is a parabola like that. It's equation 1, non-linear. And equation 2 is a circle like that. Oh, so never touch, because we have no solution. Never we have one solution. Yes. Let me show you. In what case you have no solution? Only one. XY. Suppose that we have a circle like that. And we have this is equation 1, no? And we have a half of parabola like that. Equation 2. Not the full parabola, no, half of parabola. We have one solution with this. So you need to find, guys, more possibility in nonlinear. One solution, two solutions, four solutions, no solution. Okay. Very, very weird infinity many solution. Very, very weird. Yeah. Yeah, it's possible, but it's very, very weird. Let's see example. So far, everyone understand very well the thing we are studying now. This is introduction, motivation, nonlinear system of equation in two dimension. And we have different possibility. The good thing is, okay, using Desmo, you can verify your solution super good. Now we are doing by hand, and actually in the reading test, I want you are solving by hand, and you checking in Desmos, no? Let's do it. Let's do example 1 first. May I erase the board?
Yes, yes.
Okay. 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 Now I want to solve in example 1. Example 1 say. Okay, the first equation is minus x minus 7y equal 50. What do you think about this equation? Is linear or non-linear? Linear or non-linear? Hey, answer me. Linear. And the second equation is x squared plus y squared equal 100. Que es obvio que es non-linear, ¿no? Because the exponent is 2. Ok, entonces, we are using similar idea, substitution or elimination, depending the example. My recommendation is you take the linear, que es easier equation. You solving the variable que contain coefficient 1 or negative 1. So you take this equation, minus x minus 7y equal 50. Now you solve for x, for example, no negative x, positive x. Okay, entonces now I propose you move, so this negative 7 stay here. This 50, I move to the left, I move to the right, x, and you isolate x. And now, this expression replace in another equation, and the x place here. Okay, let's do it. Entonces, negative 7y minus 50 square plus y square equal 100. Entonces now in this moment we have one equation that contains only one variable que es y. Of course, quadratic equation, ¿no? Pero okay. Entonces now expand this que es 49 y square minus. Yeah, it's minus because, well, I make a mistake here. This is negative, right? Okay, one important thing. Let me delete that part. Okay, we can write like that. 7y plus 50 squared plus y squared equal 100 because I don't care this negative, because this negative in my mind working like a negative 1, invisible negative 1. Invisible, no, negative 1, but when you square become positive. So you can delete every negative sign inside the parentheses. So you expand this as 49 y squared plus, no minus, plus, because it's plus, 700 y. Where come from 700? It's a multiplication, 7 times 50 times 2. When you fold it, you have 2 times the multiplication both, plus 50 squared gets 2500, plus y squared equal 100. Entonces, in this moment, I have quadratic equation. Let me try to manipulate and put in a standard form. Putting standard. Entonces, 49 and 1 together is 50. 50y squared plus 700y plus, I move this guy to the left like a minus 100, entonces 2400 equal 0. So far, everyone follow me? Do you understand very well everything I am doing, or I need more clear explanation? Do you understand how I can expand 7y plus 50 square? Clear or not clear?
Clear.
Clear. Okay. In this case, I can see it's possible divided by 50 everything. In other case, maybe no, but in this case, yes. And this is what y squared, and 700 divided by 50 is 14, and 2400 divided by 50 is 48. Wow. And we have super easy quadratic equation that we can solve by factorization, maybe because the combination in this case not too hard to find, is 8 and 6, because 8 times 6 is 48, 8 plus 6 is 14, plus. Therefore, y plus 8 is equal to 0. Therefore, y is negative 8. And y plus 6 equal to 0. Y is negative 6. And we finish. No, I need to find x and y both. To find the x value, I recommend you plug it in either equation, but no. It's easier doing it that way because I have isolated the x waiting for us. Look. So x is equal -7, for example, times -6. I select that value. -50, no? -50. This is positive 42. -50 is -8. And y is equal -7 multiplication by -8 minus 50. This is 56 minus 50 is 6. Okay, this is x value. Sorry, this is x value. Why no? Okay, x value. Conclusion. Let me summarize. Conclusion is we have a point. Okay, the point -8, comma, +6. Perdón, comma, -8, comma, -8, -8 here is +6. No, wait. -8, -6. A ver. Okay. Yeah, I'm making a mistake here, I suppose, no? It's positive. 56 is 6. Yeah, positive. -8, comma 6. Okay, I using the y value, no? -8, y I obtain +6. Okay. And -6, comma. Okay. Mistake, no? This is, I am crazy today. Look, x value, x comma y. Who is x in the first point? -8, comma. Where come from -8? Using -6. Okay, this -6, plug it in here, give me this. Another solution is x6 positive, comma, -8. Okay, this is the answer. Guys, do you understand? Because I make a no good explanation. I confusing. This is my third class guy teaching. No? That's, I'm a little bit tired, but it's okay. Everyone follow me? Okay.
Yes.
Yeah. Now I want to illustrate this in the Decimos, no? I be able to verify this. I open Decimos. Okay, let me try. Okay, good. Do you see Decimos? Let me see the example 1. Oh yeah, example 1 is this. Look, wow, make it zoom. The first equation is a line. Look, the blue guy. Let me flash. The second is a circle, non-linear. Intersection is 2 points. This is the point solution. Make sense? Fantastic, clear? Answer me, guy.
It's clear.
It's clear. Okay, let's move on to the second example. Okay, similar, very, very similar. Okay. Example 2. Okay, example 2 is one equation is linear that represents graphically a line 2x plus y equal 5, linear, and again a circle x squared plus y squared equal 50. I suppose that you recognize this equation in color algebra is a circle where the center is in the origin 0, 0, and the radius is square root 50. Okay, because the equation is x squared plus y squared equal r squared. Okay, but this is not important. Okay, we are doing similar. You take the linear equation, solve for the variable que contain coefficients 1 or -1, que es y in that case. So you solve for y is equal 5 minus 2x. And now substitution, this y here, in that place. And we have x squared plus 5 minus 2x squared equal 50. Okay, now expand. When you expand this guy, is x squared plus 25 is 5 squared minus multiplication, this is 10 times 2 is 20 plus square this is 4 minus 50 equal to 0. Because I know that we ending in quadratic equation, therefore I try to express it in a standard form. So combine letter, this and this together is 5. Minus 20 x, because we have only one linear factor, and this is minus 25. Because it's 25 positive minus 50 is negative 25. Okay, we can divide by 5. Nice, I love it that. Divided by 5, divided by 5, divided by 5. So x squared minus 4x plus minus 5 equal to 0. I suppose that by factorization is possible. The combination is obvious que 5 and 1. What sign? Negative 5 and positive 1. Now the x value is 5 x equal 5, x plus 1 equals 0, negative 1. This is the x value. In order to find the y value, substitution this and this and this equation. Y is equal 5 minus 2 times 5. I take this. This is 5 minus 10 is negative 5. If you want, you match it now. This is the point, que es 5, negative 5. Because we're using the x que I plug in the y equation, and you get exactly corresponding with the y. Now I take the second. Y is equal 5 minus 2 times negative 1. So it's 7, no? Because it's 5 plus 2 is 7. Now the second solution is the point negative 1, 7. This is my answer. This and this. This 1 point, and this is 1 point. ¿Es easy o no? ¿Es easy o no? Let's check it out on decimals. Okay, there you go. Do you see this one? Example 2. Look. Circle. The circle is the nonlinear equation. Line is a linear equation. Solution is negative 1,7 and 5, negative 5. ¿Es easy o no? This test is easy. In pre-calculus, the second test is easier than the first one. In my opinion, no? I respect another opinion. Okay. You have question or no? No?
No questions.
Moving on to the whiteboard to see another example. Example 3 now. In example 3, you have two nonlinear equations. Okay, the first equation is x minus 5 a squared plus y squared equal to 25. Equation 1 que es nonlinear. And another equation que es y equal 3 times square root x minus a. Equation 2. Both nonlinear. Because the first one, the exponent is 2, and the second one, this is square root. The square root is a nonlinear function. You know que nonlinear square root function look like that, square root something. Okay, and this look like circle, but I have no idea how. Well, yes, it's a circle with the center. It's located at the point 5, 0. This is h, this is k, and the radius is 5. Entonces this and this parábola. Pero I don't know. Let's see in this mod. But this is easy algebraically because I take advantage. Que y is already isolated waiting for me. Therefore, I don't need to do anything, only substitution this expression here. That's it. So we have x minus 5 squared plus 3 times square root x minus a squared equal to 25. Okay, let's do it. Expand this. Square the first, minus 2 times 5x, 10x, plus 25. Plus, square this is different because it's monomial. Since monomial is 3 squared is 9, multiply something. And you know, a square root and a square cancel out each other. This is x minus 8 equal to 25. Okay, nice. I suppose it look like quadratic equation. Let me manipulate in order to express in a standard form. It's a 9x minus 72 minus 25 equals 0. So I apply distributive property here to eliminate the parentheses. And now we combine later. Well, okay, it's easy because look at that. What happened? 25 is cancelled with 25. This is x squared. This is minus 10 plus 9 is 1, minus 1. And minus 72. Always you can use a quadratic formula. And all in the case when this is easy to see the factorization, in my opinion, it's better do the factorization. In this case, it's obvious that the combination is 9 and a. 9 times a is 72 and 9 minus a is 1. So it's negative 9 and positive. One solution is 9 positive. Another solution is minus a. Okay. And you are smart. In order to find the y value, use substitution the x value in the expression que your opinion should be easier, or Another clue in the expression que y is isolated, no? Y is equal to 3 times square root. Suppose 9. 9 minus 8 is 1. Square root 1 is 1. 1 times 3 is 3. Super. Entonces the point is 9,3. It's one solution. Another solution is 3 times square root and negative 8 is negative 8 and negative 8 is negative 16. Wow. Okay, 3 times square root negative 16. You know, this is imaginary. And when you get imaginary solution, it's because do not exist. In algebra, this is clear. When you try something, you don't know anything about this something, and in the middle of the process, you get imaginary or complex solutions because do not exist. So this is no solution. This is no solution. We have only one solution. This doesn't work. The only solution is this. And make it sense when you see the idea in this, you see more clear. Okay, in this case, it's a circle. One equation represents a circle. Another equation is the half of parabola. Okay, look at that. This one now. Example 3. Oh yes, look at that. It's a circle. Okay, the circle is black color. The center is located at the point 5,0. And the other half of parabola, because when you compute the square root, you take only the positive solution. I don't see positive or negative solution. No, only one. So we have one half of parabola, and the only point intersect is the point 9,3 is the only solution that we have. Clear? Clear or no? See, we have the parabola, the entire parabola. Let me copy and paste. Copy. Control C. Enter. E. And you change the sign here like a minus. You have the entire parabola, no? And you have two solutions, but no. The problem say only positive. Okay? Good or not good? Let's move on to the next example, the number 4, no? Number 4. Okay, we are working with the nonlinear system of equations in 2 dimensions. In 3 dimensions is crazy. Entonces, suppose this example. Example 4, no? I call. Yeah. This is 2x squared plus y squared equals 17. Equation number 1, que es nonlinear, of course. The second equation is x squared plus 2y squared equal 22, que es also nonlinear. Entonces, in this way, when you have nonlinear is we cannot take advantage. Okay, y linear or x linear, you isolate, you apply substitution. No. In this case, it's impossible. Therefore, you apply elimination. Elimination, for example, you multiply this equation. You multiply this equation, no? All right, you see? 2x squared plus y squared equals 17. X squared plus 2y squared equals 22. Okay, there are many ways. You multiply this equation by negative. What is my intention? Well, my intention is when you multiply this equation by negative 2, this is not the only way, of course, is you have minus 2x squared. This is ready to elimination. Look, minus 4 y squared equal minus 44. And this is my new equation too, by the way, is equivalent to the original. There are no differences. And you put together the original one and the new two together. 1 plus 2. Es obvio que todas partes cancel. This was the intention. In this case, we have positive 1, minus 4 is negative 3 y squared, and this is negative 44, and 17 is negative 27. Okay, we are confront 27, 44 minus 17. Okay, I check out the calculator. 44 minus 17. Yeah, it's 27. Of course, it's negative 27 because you put a sign of the bigger number, get 44. Finally, divided by negative 3 both sides. Y squared is equal 9. Oh, it's quadratic equation. You apply square root both sides. Y is equal square root 9 is 3, but plus and minus. So we obtain two solutions. Y1 equal positive 3. Y2 equal negative 3. And y2 is negative 3. Okay, so for each solution, suppose for y1 equal positive 3, I substitution where? Well, in either equation, I select number 2 again. Either equation, guys. But number 2 no transformer. By number 2, the original number 2, this one. Or number 1. See, you substitution on the 1, you get the same answer. The answer do not depend on the equation. Okay, you substitution because we are finding the common point. In this common point share x and y. Entonces I select this equation, que es x squared plus 2y squared equal 22. Entonces substitution for 3 is x squared plus 2 times 3 squared equal 22. X squared plus 3 squared is 9, and 9 times 2 18 equal 22. Okay, now solve for x. It's 22 minus 18 gets 4. When you find the x value is x equal, you find square root both sides, no? X equal plus or minus 2. So the idea is this y1 derivate two values for the x, que is 2 and negative 2. So we obtain in this part 4 points, que is the point 2, 3 and negative 2, 3. Remember, this is the x value and this is the y value. This is the x value. Now, similar idea happen when you using y2. Y2 is negative 3. So you substitution here, x squared plus 2 times negative 3 squared equal 22. And you see that we get exactly the same answer. And there's one shortcut to make easy. Look, instead of you put here, positive 3, you put plus and minus. And you get exactly the same answer because when you square positive 3 or negative 3, the answer is 9 times 2. So we get the same answer. Therefore, we don't need to continue here. It's the same. Therefore, we have another point, is the point 2, minus 3 and negative 2, no? Negative 2, positive 3. No. Wait. Okay, wait. We are working with the negative 3, negative 3, negative 3. Okay, it's negative 2. It's 2, positive and negative 2, corresponding with the negative 3, is the y2 value. And y1 is 3. That's the reason it's 3 positive and 3 negative. In total, we have 4-point solutions. So you listing, for example, the solution set is 2,3 minus 2,3, comma, 2, minus 3, comma, minus 2, comma, minus 3. 4 points. Wow. So now it's confusing, no? At least for me, it's confusing, no? And then I simulate, and that's to understand much better the situation, no? This is example 4. Let me try. Do you see Desmond? Can you see? Look at the example 4. Example 4 is 2x squared plus y squared equals 17, and x squared plus 2y squared equals 22. Look, no, this, boom, wow. We have 2 ellipses, the orange and the purple color. And the intersection of 4 points is the point we found before. Clear? This is important. So, the geometric interpretation is possible doing in 2 dimensions. In 3 dimensions, it's impossible. Well, it's possible, but it's too hard to see. Linear is hard, and linear is plane. But si es non-linear in 3D, it's no plane, it's surface. Spheres, ellipsoid, something weird. No, not good. Okay, everything is clear so far or no? Clear so far or no?
Clear.
Yeah.
Okay. Okay, let's move on to the next example, that is super easy. Do you see what more?
Yeah.
Okay. This is example 5, no? Okay, the example 5, we have that situation. Okay, suppose x squared plus 4y squared equal 4. Equation 1, non-linear. X squared minus y squared equal 9. 9? Yeah, 9. Equation 2. This is a system, non-linear, non-linear both. Entonces es obvio que in this case impossible doing by substitution. Entonces now I saw que by elimination is possible if you multiply this equation by 4. By 4. Because I take advantage positive 4 and negative 4, no? You multiply the equation 2 by 4, we have 4x squared minus 4y squared equal 36. And this is my new equation 2 is equivalent 100% with the new equation. So I working basically 1 and 2 new. 1 plus 2 new is 5. Because 1 plus 4 is 5. This is cancelled. And it's a 40. Because 4 plus 36 is 40. Divided by 5 equal 8. Square root both sides. X is equal plus or minus square root 8. Okay, you know A is 2 and 4. I know que square root 4 is 2, entonces plus or minus 2 radical 2. Okay, this is solution of the x value. You substitution to find the y value associated with the x value. Okay, it's common, same point. Substitution in either equation, I recommend using the easier equation, okay, is 2. So I take this again, and x equal to radical 2, or radical a, either way. It is, you can plug it in both. Remember the idea. Because the square, it doesn't matter if it's positive or negative, give me the same answer. Minus y squared equal 9. This is 8. It's obvious, right? Because a square power and a square root cancel out each other. It doesn't matter if it's positive or negative. The answer is always positive. And now you solve for y. Solve for y is 8. Stay here, minus 9. I move to the left, and y squared move to the right. This is a negative 1. Okay, you apply square root both sides. You feel, wow, it's imaginary. This is I, plus or minus I. What's mean que es imaginary? What do you think happened when it's imaginary? What is the interpretation? You see in decimal after, no? I promise. But what is the interpretation? You have no idea? Remember, I repeat one more time. In algebra, when you try to find something and the answer is complex or imaginary, it's because it do not exist. So what is the answer in this problem?
No
What is the answer?
solution.
Exactly. Exactly. No solution. Perfect. Let me see in decimal to understand more clear. You see decimals?
Yes.
Look at example number 5. In example number 5, we have two nonlinear equations. The first one look like ellipse. Look, let me flash. And the second one is hyperbola. And you see can never touch. You see can never touch. Therefore, no solution. This is the idea. Clear?
Yes. Yeah.
Beautiful. One more, and that's it. One more, and that's it. Do you see one more?
Yep.
Okay. Example one number 6, no? Okay, the conclusion is, guy, in nonlinear, we have no rule. We have, it's totally crazy. You using your imagination. When the one equation is linear, you take advantage, que es linear. And you apply substitution. When the both equation is non-linear, maybe substitution, maybe elimination, or another method. Okay. And this system both are non-linear. So it's obvious that we can apply elimination. I don't know why in my paper I multiply this equation by, well, I know, multiplication by -4. But another possibility is multiplication by -1. But it's okay. Either way. The thing is, it doesn't matter the way that you are doing. If you are doing well, you get the same result. This is the beauty of mathematics. When you multiply the entire equation by 2, we have -4 x squared plus 4 y squared, because negative times negative is positive, equal -12. Equation 2 new, because -4 times 3 is -12. and this together is negative 3 x squared. This cancel out, equal 72 minus 12 is obvious, is 60, no? 60 divided by negative 3. Negative 3, negative 3, negative 3, negative 3. And the square root of side. Maybe something is wrong here. Okay. Now let me check. See if I copied wrong. This is negative 4, 72. This is positive 3. This is y. This is negative 3. Do you see something wrong or everything is okay? Do you see something wrong or everything is okay? I don't understand. 16 x squared. Yeah. The problem is I copied wrong the problem. Okay. Let me erase everything I copied right. Well, no, I fixed it. Look, this is 16. The original problem is here, 16. And the paper, is in the stable part, so I don't see the 16. Okay. Entonces 16 minus 4. So the procedure is the same. 16 minus 4 is 12, no? It's 12. Divided by 12 both sides. F5. And the square root both sides is plus or minus radical 5. We have two solutions. Okay, radical 5 in decimal is square root 5 in decimal, because in decimals, when they see in decimal, you don't see square root 5, you see square root 5 is in decimal 2.24 approximately. Plus or minus 2. Well, actually decimal offer 3 decimal place, 23.6. I have to see in decimal. However, in the paper, no decimal approximation, no exact answer. Now, in order to find the solution, you plug in the easier equation, in my opinion, is the equation 2. This equation. Now, x is plus or minus radical 5 squared. I plug in both because the square becomes positive everything, minus y squared equal 3. This is 5 minus y squared equal 3. Therefore, 5 minus 3 equal y squared. 2 is equal y squared, square root both sides. Y is equal plus or minus radical 2. We have 4 solutions. What is the 4th solution that we have? Well, we have, you can write like that, plus or minus radical 5 and the x and corresponding plus or minus radical 2. Actually, it's 4 solutions, no? Using plus every combination. Plus. Okay, you copy like that. Radical 5, radical 2, comma. Radical 5, comma, minus radical 2, comma. Minus radical 5, comma, radical 2, comma. Minus radical 5, comma, minus radical 2, comma. for solution. You see that? Let's check it in decimals to make sure that everything is okay. Okay, example 6. It's 16. Look, I don't copy, right? We have two hyperbola. Look, oh, nice. Look at that. We have two hyperbola. The first hyperbola is the blue hyperbola, and the other hyperbola is the green hyperbola. Have 4 common endpoints. Plus or minus radical 5, que es 2.236. And radical 2 is 1.4014. Is the fourth solution. Very good, guy. Do you see? Okay, this is a nonlinear, easy. Next time we're discussing inequality in 2 dimensions. Inequality in 2 dimensions and application, their application. Okay. Too much for one day. And leaving, I wish you have a nice day, okay?
Have a good day, Professor.
Thank you, Professor.